and I'm going to get a negative 5. So I'm going to put a negative 5 and a 33. So it's greater than or equal to a negative 5, but it's less than or equal to a 33, which means it's bounded in the middle. Okay? 22 is going to be the same way. I will set up the equation, I'm just not going to solve it. So for the positive, I leave it exactly the same, no inequality symbol changes, but when I make that the negative 15, I'm going to go ahead and reverse that inequality sign. Still solve it the exact same way. 23 and 24 are going to be the exact same problem, so remember that you have the positive version, reverse the inequality, and you have the negative. Okay? Okay, so once you've solved those, you can put them on the number line. Now 25 and 26 are graphing linear inequalities, so these are old problems. We graph the line and then we decide are we shading above or below. So if I look at this one, it has a y-intercept of negative 2. I'm going to start at negative 2. It has a slope of 1/3, which means I'm going to rise 1 and run 3. So I'm going to rise 1 and run 3. Once I have my 2 points, I can go ahead and connect those. When I look at my inequality, it's a less than, it's not an equal to, which means I'm doing a dotted or a dashed line to represent the graph. If it is a less than equal to, greater than equal to, I go ahead and use a solid line. Now I need to decide where should I be shading. It's saying it wants everything below this, so I'm going to shade everything underneath my line. Remember that if you can't remember which way to shade, you can always pick a test point and shade according to whether or not that test point is true. Now 26, still linear, still just graphs the line, but I need to get it into the Y format first. So the first thing I'm going to do is I'm going to move this 2x to the other side. And then I will divide by 6. So 18 divided by 6 gives me a 3. 2 divided by 6, I'm just going to leave that as a fraction because I really don't want a decimal because we are graphing, so it is a rise over run. So I get 3 minus 1/3. So 3 is my y-intercept. Now my slope is a negative 1/3. This time y is greater than or equal to, which means solid line. And then I'm supposed to be shading everything greater than that. So I'm going to go ahead and shade above. Now 27 and 28, these are new for this unit. So you are graphing the absolute value inequalities. So you have to graph your absolute value, which is a v, and then you have to shade according to the inequality. We graphed absolute values back in Unit 2. Remember that the parent function starts at the origin, and both sides have a slope of 1/1. So anytime I have a number in the front, that is going to change that slope or shrink it or stretch it. Anything on the outside is an up or down move. Anything on the inside is going to be a left or right move. And remember that our insiders lie, so it always does the opposite of what it looks like. So on this one, I'm going to move it down 2 units. And then my slope, instead of being up 1/1, is now up 3 and over 1 in both directions. It's just a greater than, which means I'm just going to use a dashed line to connect these. Then it's saying y is greater than. So I either need to shade inside the V or outside the V. If it's saying greater than, I'm going to shade inside the V. That does change if you reflect your absolute value graph as far as which way you shade. All right, so 28 is basically the same. The only thing is you're going to have to add this 1 over to the other side first. So now this becomes an up and down move. This becomes a left or right move. Remember that it lies. So this looks like I would be moving to the right 2, but I'm actually going to go to the left 2 and then up 1. From there, I don't have a stretch or a shrink, so my slope on both sides is just 1. It's a less than or equal to, so I'm going to go ahead and connect those with a solid line. And this time we're saying y is less than or equal to this, so I'm going to go ahead and shade everything on the outside. All right. 29 is not even an inequality anymore. It's just a regular absolute value. So if I graph y equals the absolute value of x plus 4, moving it up 4, and then my slope is 1. So there we go. If I want to graph negative absolute value of x minus 3, so I'm going to move it down 3. This negative on the outside tells me that now it is opening down. Still a slope of 1, but opening down. All right, how would you write negative 4 is less than or equal to x, which is is less than x, which is less than or equal to 7 in interval notation? The easiest thing to do is go ahead and put this on your number line. So negative 4 to 7. We have an open circle to a closed circle. So interval notation, remember that open circles are parentheses, closed are brackets. So if I wanted to write this in interval notation, it'd be negative 4 to 7. Open circle is a parentheses, closed is a bracket. Same thing right here. If I'm going to go from negative 1 to 8, this time I'm closing both ends. So this is a bracket, this is a bracket. So from negative 1 to 8. Okay. All right, domain and range. This is a review. So domain, remember, deals with my x's. So this is essentially a quadratic graph. We know that when we are looking at a standard quadratic graph, our domain is negative infinity to infinity. It's all real numbers. Now our range is, you can't even see that, sorry. Our range is based on our y, so bottom to top. So it doesn't go all the way down in the bottom, it actually starts at 2. It's touching 2, which means it's inclusive, so bracket, and then it just keeps going up and up and up, so all the way to infinity. Okay. All right, I will go back through and continue working these so that you can see all the problems, but whichever videos you want to watch, that is up to you from this point. So let's look right here. I have my fractions. So the first thing, I need to get the x by itself. So I'm still going to go ahead and subtract this 1/3 to the other side. Now, back in my day when we had to subtract fractions, we had to do it by hand and we had to get a common denominator. So the number that 4 and 3 both go into is 12. So I would have to multiply the 4 by a 3 to get 12, which means I also have to multiply the 3 by 3 to get the 9. Over here, I'd also multiply 3 by 4 to get 12, so I multiply the top by 4. So I really get 9 twelfths minus 4 twelfths. So 9 minus 12 is 5, and then my denominator stays the same. So I have 5/6 equals 5/12. Okay. From here, you can butterfly, cross multiply. So I get 5x times 12, which is going to give me 60x, and then I get 6 times 5, which is 30. To get x by itself, I'm going to divide by the 60. So x is 1/2. Okay. All right. Right here, I'm going to go ahead and add 5 to both sides. So I'm going to get x over 3 equals 18. I can cross multiply this one also, I just make the 18 over 1. Or I can just multiply both sides by a 3, because right now I'm dividing by 3, so the opposite operation is to divide. Is to multiply, sorry. It doesn't really matter. You should get the exact same answer. So 18 times 3 is 54. Let me just check. Yes, 54. So that is my answer. All right, we finished all the other ones on this front page, so let's go ahead and flip to the back and see what else we have. All right, so on 9 and 10, we have more absolute values. So remember that we have to set up, I didn't even read the whole question. Can the absolute value be equal to a negative number? No. So I know that this one has no solution. Over here, I need to get the absolute value by itself first, so I'm going to add 2 to both sides. But I still have that 3 in the front, so I'm going to go ahead and get rid of that. So I end up with the absolute value of y is equal to 3. Well, that's pretty simple. The absolute value of y equals 3. If I break it down, y equals 3 and y equals negative 3. Okay? All right, we finished all of the rest of these problems on this page. So let's go ahead and go over here to number 20. So on number 20, I'm just going to solve these separately. So I'm going to add 1 to both sides. 6y is greater than 18. I'm going to need to divide by 6, so I get that y is greater than 3. I need to solve this one also, so I'm going to add 6 to both sides. So 8y is less than or equal to negative 4. I'm going to divide by 8, so I get y is less than or equal to a negative 1/2. Both of my numbers need to go on my number line, so negative 1/2 and 3. On the 3, it's saying that y is greater than 3. So open circle because it's not actually equal to, and then I'm going to go to my right. Over here, it's saying that y is less than or equal to negative 1/2, so it is a closed circle this time because it can be equal to. And less than, I'm going to shade everything to my left. Okay. On 22, we went ahead and started those equations. We set them up. Now all we need to do is solve them. So I'm going to add 1 to both sides. So I get 6k is less than 16, and then I'm going to divide by 6. So k is less than, I can divide both of these by 2, so I get 8/3. Let's go ahead and add 1 over here. So I get 6k is greater than a negative 14. So I'm going to divide by 6. So I'm going to get that k is greater than a negative 7/3. Alright, so both of my numbers need to go ahead and go on my number line. So I've got a negative 7/3 and I've got a positive 8/3. It's greater than a negative 7/3 and it's less than 8/3. It's not equal to, so both of these are are open and then bounded in between. Alright, we set up the equations on 23 and 24. 23, I just need to go ahead and finish solving. So I'm going to subtract 7 from both sides. So 2r is greater than a negative 6. Divide by 2. So r is greater than a negative 3. Over here, I'm going to subtract the 7. And I get a negative 8. And then I'm going to divide by 2. So r is less than a negative 4. So both my numbers need to go on here. So negative 4 and a negative 3. So it's saying that r is less than a negative 4, open circle, greater than a negative 3. Okay, less